This is Module 12, Lesson 3, Using Data. After this lesson, you need to be able to identify any potential bias in the statistics or the representations of data. Let's learn using statistics and representations. A statistic is a measure that describes a characteristic of a sample. Like data, statistics and representations of data are non-neutral. When the average of a set of data is discussed, it uses a measure of center, either mean, median, or mode. However, depending on the data set and what information is being conveyed, one measure of center might not give the whole picture of the data. Even if the data is being discussed in whole, it can be misrepresented. For example, a person might manipulate the scales of the axes of a graph or how the data are represented graphically to misrepresent the data. In the next couple examples, we're going to look at how people might use data to mislead you. So be on the lookout for these types of things. We're going to skip to example 3 and learn about data summaries. So our real world context here is teaching. A teacher wants to tell his students how the average student did on an exam. So he looks at the scores in his gradebook. 2 students scored a 0 because they stopped showing up for class in the last month and did not take the exam. So this must be a college class. He uses the mean of 71 as the measure of center. Does that mean accurately represent the data? So other students scored, we had our 2 that had zeros, we had an 82, an 83, an 85, an 87, 2 88s, and 3 that scored 91. So is 71 accurate when looking at the other scores? To determine if that's the appropriate one we should be using, we're going to look at the other 2 as well. So we need to identify the median and the mode. The median, as a reminder, is the middle number when they're in order. These are already in order, so we can find the middle. I cross 1 out on each side. My middle is 87. Another way you can find the median is count how many numbers there are, divide it by 2, and then if it doesn't come out evenly, so let's say it was 6.5, then you would round up and pick that number from the beginning. So here there were 11 numbers. If I divided it by 2, I would get 5.5. 5.5 rounded up is 6, so I circled the 6th number. The other one we need to figure out is the mode, which is the number that shows up the most often. So the mode here is 91. It showed up 3 times. We're going to use these 2 numbers to compare it with our mean to see if the mean is actually a good representation. So our next step is then to analyze the other measures and how they align with what the teacher wants to convey. So we're going to look at each of them. The mean, which was 71, is affected by those 2 0 scores. Okay, those zeros brought the number way down. If we were to look at the other data, no one who showed up for the exam scored below an 82. So saying that the average student scored 71 isn't really doing a good job because everyone that showed up had at least an 82. So the mean is not really a good statistic for this situation. If we look at the median, which was 87, it is not affected by outliers, which are numbers that are really far away from everything else, like those zeros. Here, it's providing a more accurate average for how students performed, because yes, it still includes all the scores, but the ones that scored really low didn't pull down the middle. If we were to check the mode, which is 91, is the score that most students received and the highest score, but it's not accurate on how the average student performed. Even though it had the most occurrences of 3, that means that 3 students got it, but all the rest of them did not. So 91, not necessarily the greatest. If 91 had been more towards the middle, then maybe we would use it. But when it's the maximum or the minimum, it's usually not the best. Going back to our original question of, is 71 a good representation? We would say, because the teacher wants to discuss those who took the exam, the mean is not the best measure. Okay, using that one indicated that all students took the exam performed worse than what they got, which, might make some students feel better. Hey, the average student had 71. You're thinking to yourself, oh, I got 85. But 87 is really more the middle. Check your understanding of when to use mean, median, or mode. Read through the situation, then pause the video and determine if the mean accurately represents the data. Choose the best answer. Check your answer. In this one, we have 5, 6, 4, 5, 5, 6, 5, 4, 5. I'm going to put the numbers in order real quick. So we have 4 twice, 5, 1, 2, 3, 4, 5 times. So 5 fives. And 2 sixes. So if we're going through our steps to determine if it's accurate, she got mean was 5. So the mean is 5. We need to figure out if the median and the mode also are around here. So median is the middle. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 9 divided by 2 is 4.5. So the 5th number, which means the median is also 5. And our mode, there are 5 fives. The mode is 5. So, is the mean an accurate representation? If the mean's 5, the median's 5, the mode's 5, I would say 5 is probably in the middle, an average number. So A is no, the mean's overly influenced by the low numbers. The 4 doesn't really pull it down. Influenced by the high numbers. The 6 is not really pulling it up. The mean doesn't tell you how many pages are in the average book. You might be thinking that this is an important thing to think about, but it's just asking the number of books. So yes, some of the books might have been like 5 pages, and some of the books might have been 300 pages. But we're just counting the number of books, not how many pages. So yes, I would say the mean accurately represents the data, since the mean, median, and mode are all about the same number. In fact, they are the same number. Example 4, data summaries. Our real-world context is soccer. A group compares 2 soccer players who play the same position for different teams. They make a graph of the number of goals scored throughout the season for each player. Do the graphs misrepresent the data? Whose interests might be served by the representation? So we have 2 things we want to know here. Are the graphs misleading? And who might benefit by the representations? So we have player 1 here. If we look, they have their goals scoring going up. And player 2, we have another line showing their goals going up. We will keep jumping back to these graphs as we look through what we need to find out. So first, we're going to identify misleading representations. So what is the purpose of these graphs? In these graphs here, our purpose, if we look, we're looking at the total goals by our two players. So our purpose here is to show the goals that each soccer player has scored. Next, we're going to identify any differences in the graphs. So if we look at it, what are some differences? They both say total goals. One's player 1, one's player 2. They both say the months. If we look at our axis on the bottom, they're the same number of months. Our difference, and our main difference here, is the scale. If you look at player 1, it counts up by 5s. Whereas if you look at the scale for player 2, what is it counting up by? 10s. Now, you might not think that would be important, but it is a difference. So, the graphs do appear to be the same, but the y-axis for second player goes up to 90 in increments of 10, whereas the first player goes up to 45 in increments of 5. Our next step then is to identify how that would affect the representation of the data. Although the numbers are the same, the scale for player 1 makes it look like he's scoring more goals than player 2. So if we go back and look, you can see that it looks like player 1's graph ends a lot higher than player 2. But if we look at the line where it ends, it ended at 30 goals for player 1. Where does player 2 end at? Also at 30 goals. They scored the exact same amount of goals in the same amount of months, both in 8 months. Player 1's scale is just smaller, so the line looks like it went up faster, even though it really didn't. So pay attention to how things are graphed. So our second part to this was whose interests are served by doing this. The misleading representation of the data we saw makes it look like player 1 scored more goals than player 2. We know that wasn't the case. Who could that serve? Well, that could serve the interests of player 1. If people who are not paying attention see the graph from player 1, they're thinking player 1 gets more goals. Oh, player 1 might get more sponsorships. Player 1 might get more money. Player 1 might get a better contract, so their agent might get more money. Whereas player 2 looks like they scored less, even though they didn't, might miss out on some things. So hopefully the people in charge are paying attention to the scales on the axes.